Before you begin this lesson, you're going to want to be sure that you understand what a function is. We have defined a function as a relation or a set of ordered pairs where no two distinct ordered pairs have the same first coordinate. Or stated another way, we mentioned that if we put in a value for our first coordinate, we get only one unique answer for our second coordinate. In this lesson, we're going to look at function notation and also some operations involving functions. Function notation. When an equation represents a function, we often use function notation. For example, the equation y equals the square root of x minus 2, which is a function, can be written as f of x equals the square root of x minus 2. Let's stop right there for just a moment and talk about a few things. First of all, notice that we're saying when an equation represents a function. We know that not all equations are functions, so this notation is reserved only for those equations that are a function. If we decide that a given equation is in fact a function, we may use in place of the y this symbol which we read f of x. This is indicating that we have a function of x, meaning x is the independent variable or the first coordinate in our ordered pairs. Notice that any letter may be used to represent a function, but common choices are f, g, h, and k. That's sort of like with our equations, we get kind of in the habit of using y's and x's, although we know those are not the only letters that we may use for an equation. Similarly, we tend to use these same letters over and over for functions, although we can use any letter that we choose. This is very important. Notice that the function notation is a replacement symbol for y. So it represents the second coordinate in an ordered pair when x is the first coordinate. So this symbol f of x means the same thing that y means. And we know that since we put y as the second coordinate in our ordered pairs, then this f of x symbol is talking about the second coordinate whenever we use x here as the first coordinate. Let's look at some examples using this function notation. We are to let f of x equal 5x plus 2. Now remember from what we just talked about, saying that f of x is equal to 5x plus 2 is equivalent to saying y equals 5x plus 2. So instead of f of x we may write y, or instead of y we may write f of x, because this is a function. Now when it says to find f of 6, notice in this notation the 6 has replaced the x in the f of x notation. So f of 6 means that we are replacing x with 6. Now we're going to write this down here like this. We're going to write f of 6 is equal. We're going to look at this equation and we're going to replace the x with a 6. We'll do that over here also. So replacing the x with a 6, I'm going to use a parenthesis to indicate the times, since this means 5 times x. I have 5 times 6 plus 2. Now we will simplify this. 5 times 6 of course is 30. 30 plus 2 is equal to 32. Saying that f of 6 is equal 32 is saying that whenever we replace x with 6, our second coordinate, or our y value if you will, is 32. So I want you to be sure that you understand when you say f of 6 equals 32, this is equivalent to saying I have the ordered pair x is 6 and y is 32. We want to find f of negative 4. This means we're going to do what? The x is now going to be replaced by negative 4. So in our equation, we're going to say this is equal to 5 times negative 4 plus 2. 5 times negative 4 is negative 20, so negative 20 plus 2 will give me a negative 18. Again, this is saying whenever x is negative 4, my second coordinate is negative 16. Or I can write the ordered pair negative 4, negative 18. We are then to find f of 0. F of 0 means that the x is being replaced by 0. We have 5 times 0 plus 2. Of course, 5 times 0 is 0. 0 plus 2 gives me 2. Saying that f of 0 equals 2 is equivalent to saying we have the ordered pair 0, 2. Whenever x is 0, y is 2. We are to find f of 1/2. X is now replaced by 1/2. So in our equation, 5 times 1/2 plus 2. If we put 5 over 1, 5 times 1/2 is 5 halves. I'm going to write 2 over 1 here. We need a common denominator. 5 halves plus, multiplying this numerator and denominator by 2 gives me 4 over 2, and my solution is 9 halves. Again, this is saying I have the ordered pair 1/2, 9 halves. I hope that you're seeing in this example that this notation is just a nice way of saying that we're going to choose whatever is inside this parenthesis as a replacement for x in our given equation, which happens to be a function. This f of x notation is a replacement notation for y. We like this notation because it indicates, first of all, this is a function, and secondly, because we can use this notation, which shows what we're replacing x with. Let f of x equal 3x minus 8. We are to find f of a, the quantity f of a plus h, and then finally f of a plus h, subtract f of a, all divided by h. Let's start with this first one. We learned in our last example that whatever is inside this parenthesis in the function notation is indicating a replacement for x, or the independent variable in our original function. So this is telling me that in function f up here, I'm going to replace x with a. So we will write f of a equals, replacing the x with the a gives me 3a, subtract 8. Since I may not combine the terms 3a and 8, I cannot simplify this solution. Now, we mentioned last time, this is telling me a set of ordered pairs. This is equivalent to saying whenever I replace x with a for my first coordinate, my y value is 3a minus 8. Let's look at this second one. F of a plus h. It does not matter how complicated this expression is inside the parenthesis. Notice here's our function notation. Our parenthesis includes all of this, a plus h. So a plus h is replacing x. So when we go to this equation, 3 times x, in place of x, we're going to put a plus h. I will need a parenthesis to indicate that multiplication. Then don't forget to bring down the subtract 8. Notice this looks just like this, except the x has been changed to an a plus h. Now on this one, I may do some simplifying. I may distribute by 3 across this parenthesis, 3a plus 3h, and then subtract 8. None of these terms will combine with each other. So at this point, we do have this simplified. Now, this last problem looks really complicated. We just want to do this in steps. This quantity is sometimes called a difference quotient. If you continue your study of mathematics, you will see this difference quotient again later. Now, notice here in the numerator we're subtracting two things. We're subtracting f of a plus h. Right up here we calculated f of a plus h. F of a plus h turned out to be this expression. So I'm going to put 3a plus 3h subtract 8 in place of f of a plus h. Notice then we are subtracting. I'm going to use another parenthesis here. What is it that we're subtracting? We're subtracting f of a. Here we calculated f of a to be 3a minus 8. So I will put 3a minus 8 in place of f of a. The parentheses are necessary so that we will distribute this subtract. Notice all of this is over h. Let's remove parentheses. I have 3a plus 3h minus 8. Distributing our negative, we will have a minus 3a plus 8. All of this is still over h. Now look at that numerator. 3a subtract 3a is 0. Those terms will add to 0. Negative 8 plus 8 also adds to 0. So I have 3h over h. 3h over h has a common factor of h. If we cancel our h's, we have 3 over 1, or simply 3. In this example, we're going to use a different letter here. Remember, we don't have to use f to represent a function. G of x is equal to x squared minus 2x plus 3. First of all, we're to find g of 3. Now recall what that means. X is going to be replaced by 3 in function g. G of 3 will equal, putting 3 in place of x, we have 3 squared minus 2 times, replacing x with 3, plus 3. So all I've done here is taken this equation. Everywhere I had x, I have put in a 3. Now we will simplify. 3 squared is 9. Minus 2 times 3 is a minus 6, plus 3. 9 minus 6 is 3. 3 plus 3 is 6. Now, what does this mean? If we let x be 3, our second coordinate is 6. Remember, this is equivalent to saying if I put a 3 in for x, my second coordinate is going to be 6. Find g of negative 1. In function g, x is being replaced by negative 1. So everywhere we see an x, we're going to put in a negative 1. I will need to be careful here. Negative 1 will be squared minus 2 times negative 1 plus 3. If we square negative 1, we get a positive 1. A negative times a negative gives me a positive 2, and then I have plus 3. Adding, I get 6. So we're saying if we put a negative 1 in for x, our second coordinate is 6. In our third part, we are to find g of 3x. Now, what does this mean we're doing? X in the original function g is being replaced by 3x. So in place of this x, I'm going to put 3x. That has to be squared. Minus 2 times, in place of this x, I'm putting 3x. And then bring down the plus 3. Let's simplify. If I square 3x, I have 9x squared. Multiplying here, I get a negative 6x and bring down the plus 3. This is all the simplifying that I can do in this example. All we're doing, recall, with this function notation, whatever is inside the parentheses is a replacement for this variable in the original function. Let k of x equal 2x squared plus 5x minus 2. We are to find k of a plus h, and the difference quotient, k of a plus h, subtract k of a, divided by h. Let's start here. K of a is telling me to go to this function I've identified with the letter k and replace x with a. So in this equation, I'm going to replace the x with a. 2a squared plus 5 times a minus 2. I have replaced the x with an a. Find k of a plus h. Again, this is identifying function k. The x is to be replaced with a plus h. So I'm going to have a 2. I'll need to use a parenthesis. A plus h is replacing this x. I then need to square, plus 5. In place of this x, I'm putting a plus h, and then minus 2. Now, in order to simplify this, let's bring down this 2. We have to do exponents before we multiply. So let's square a plus h. Recall, when you square a binomial, you square the first term. That will give you a squared. Multiply the first term times the second term. That will be a positive ah. You double that, or times 2. So I will have a plus 2 times ah. And then you square that second term. If you square a plus h, you get a plus h squared. Let's go ahead and distribute our 5. We have a plus 5a plus 5h, and then subtract 2. Now we need to distribute our 2. We have 2a squared plus 4ah plus 2h squared plus 5a plus 5h minus 2. Notice that none of these terms are like terms. We may not simplify that anymore. Finally, our difference quotient. We want to find k of a plus h, subtract k of a, and divide all of that by h. Well, first of all, we're going to put in this k of a plus h, which we did here. 2a squared plus 4ah plus 2h squared plus 5a plus 5h minus 2. Then we're going to subtract. We'll use another parenthesis, k of a. Here's k of a. 2a squared plus 5a minus 2. And then all of this will be over h. Now let's do some simplifying. We will remove the parentheses. 2a squared plus 4ah plus 2h squared plus 5a plus 5h minus 2. Distribute your negative. Minus 2a squared minus 5a plus 2. All of this is over h. Are there any terms that will add to 0? I see 2a squared here and minus 2a squared here. Let's just mark those out because those add to 0. I see a 5a here and a minus 5a here. Those will add to 0 also. I have a minus 2 here and a plus 2 here. Those will add to 0. Let's write down what we have left. I have a 4ah plus 2h squared and a plus 5h all divided by h. I want you to notice that in this numerator I have a common factor of h. So let's factor that out. If I factor an h out of the numerator, I have 4a plus 2h from the second term and plus 5. Again, this is all divided by h. Because I was able to factor this h out, I can now cancel these h's. And my final reduced solution is 4a plus 2h plus 5. You may be thinking that this is really a complicated expression here. I can assure you that it has many very important uses in the real world, and so what we're wanting to learn in this class is about the function notation for you to understand whatever is in parentheses, no matter how complicated it is a replacement for x, and then just learn to manipulate this difference quotient to substitute in and simplify down to a simplified expression. Now that we have looked at the function notation, we're ready to look at some operations on functions. The operations we're going to look at in this lesson will be addition, subtraction, multiplication, and division. You're going to find that these operations operate very much like you would expect them to. Let's look at the definitions of these operations. Combinations of functions. The sum of two functions can be written with this notation. In this parenthesis, we have f plus g. This is indicating that we're adding two functions, one function identified with the letter f and the other function identified with the letter g. We still read this f plus g of x. The purpose of this part right here, remember, is to indicate that x is our first coordinate. You'll notice that what this says that we do if we're adding two functions is we simply add the f of x function plus the g of x function. You'll see that in an example in a few moments. The difference of two functions, f minus g of x, that should say equal, is equal to the first function listed here, f of x, subtract the second function listed here, g of x. The product of two functions is written like this, f times g of x. This is found by doing f of x times g of x. And our last operation is our quotient of two functions. The function f divided by g, f over g, or f divided by g of x, is equal to this function f of x divided by g of x. You'll notice I've added here that this g of x function down here cannot be 0. And of course we've put that in because denominators may not equal 0. Let's see how these operations on functions work. Let f of x equal 5x squared minus 7x plus 4 and g of x equal 8x minus 2. We are to find the sum of f and g, the difference of f and g, the product f times g, and the quotient f divided by g. Let's start with the sum. we're going to write f plus g of x. By definition, that means we are doing f of x plus g of x. And what we're going to do right here is we're going to replace f of x with what it's equal to. F of x is equal 5x squared minus 7x plus 4. And then plus, we're going to replace g of x with what it is equal to. G of x is equal 8x minus 2, so we will replace that with 8x minus 2. We have some like terms here we may add together. 5x squared, combining our x's, we have a plus 1x, and 4 minus 2 gives me a plus 2. What has happened here is that by adding the two functions f and g, we have created a new function defined by 5x squared plus x minus 2. The difference, f minus g of x, means that we want f of x subtract g of x. So again, we're going to replace f of x with what it's equal to, 5x squared minus 7x plus 4. Now, when you're subtracting, you're going to want to be real careful. Notice that this function that we're subtracting has more than one term. You'll need to use a parenthesis here. Replace g of x with 8x minus 2. The reason we needed that parenthesis is because this negative is going to distribute. So let's rewrite. I'll come down here. 5x squared minus 7x plus 4. Distributing our negative, we have a minus 8x plus 2. Combining our like terms, we have 5x squared minus 15x, and 4 plus 2 gives me a plus 6. So again, we've created a new function, f minus g. The product, f times g of x, by definition, means f of x times g of x. Let's use parentheses for multiplying. In place of f of x, we're going to put what it's equal to, 5x squared minus 7x plus 4, and then times g of x, we're going to replace with 8x minus 2. To do this multiplication, let me come over here so we have plenty of room. First of all, I'm going to multiply 8x times each of these three terms. So 8x times 5x squared gives me 40x cubed. Multiplying here, I get a negative 56x squared. And then multiplying this last term, I have a plus 32x. And then we'll come back and multiply negative 2 times each of these terms. So I will have a negative 10x squared, positive 14x, and a minus 8. Again, we're going to add like terms. I do not have any other x cubes, so let's bring that down. Sometimes I like to check those off to be sure I've taken care of everything. I have a negative 56x squared and a negative 10x squared. I'm going to add those two together. That gives me a negative 66x squared. And then I have a positive 32x and a positive 14x. We'll add both of those. And I have a 46x. And then bring down that minus 8. I have taken care of every term up there. Again, we created a new function that is the product of the other two original functions, f and g. Finally, we want to do the quotient f over g of x. By definition, this is f of x divided by g of x. So replacing f of x, I have 5x squared minus 7x plus 4, and g of x is 8x minus 2. Now, you will want to look at this and be sure that you cannot reduce. This particular fraction will not reduce. You also want to remember that this fraction down here, or this denominator down here, 8x minus 2, cannot be equal to 0. So let's follow that through. If 8x minus 2 cannot equal 0, then 8x cannot equal 2, which says x cannot equal 2 divided by 8, or 1/4. So this quotient of these two functions will be valid, will be defined as long as x does not equal the number 1/4. Let f of x equal 5x squared minus 7x plus 4, and g of x equal 8x minus 2. The first thing we're to do is to find f plus g of 6. Now I'm going to show you two different ways that you can do this. First of all, f plus g of 6 by our definition means we're going to do what? F of 6 plus g of 6. Okay? F of 6 says you're going to go to function f and replace x with 6. So let's do that. I have 5 times 6 squared minus 7 times 6 plus 4. I'm going to put that in a bracket. And then we have plus g of 6. G of 6 says you're going to go to function g up here and replace the x with a 6. So doing that, I have 8 times 6 minus 2. Now let's follow that through. 6 squared is 36, so I have 5 times 36 minus 7 times 6. 7 times 6 is 42 plus 4. And since this is a plus sign, 8 times 6 is 48 minus 2. Now let's multiply. 5 times 6 is 30. We're carrying a 3. 15 plus 3 is 18. So I have 180 minus 42 plus 4 plus 48 minus 2. That looks like a lot of arithmetic, doesn't it? Well, let's see what we might do here. I noticed that I have a couple of negatives here. I think I'm going to put those together. I have 180. Minus 42 minus 2 is a minus 44. Plus 4 plus 48. I'm kind of doing this so it'll be easy. Minus 42 minus 2 is a minus 44. Now, if I do these, I have 180. Minus 44 plus 4 is a minus 40. Bring down that plus 48. Here, I have a minus 40 and a plus 48. That's a plus 8. And finally, 180 plus 8 is 188. Of course, if you had a calculator, you could just run through those and add those up real quickly. But we're saying that we get 188. Now, I want to show you another way. In this previous example, we did f plus g of x, and we got a function form. Let me rewrite that for us over here. We got f plus g of x to be equal 5x squared plus x plus 2. Let me show you that again. When we did f plus g of x, f of x plus g of x, we got 5x squared plus x plus 2. So that's kind of like a formula, isn't it? Now, if I want to do f plus g of 6, I can look at it by saying go to the function f plus g, which is here, and replace x with 6. Let's try that here. I'll have 5 times 6 squared plus 6 plus 2. Well, let's see. 5 times 36, and I'm going to go ahead and add 6 plus 2 is 8. 5 times 36, 5 times 6 is 30, carrying 3. 15 plus 3 is 18. And look, we have 188. So you have this choice of doing this problem. You can evaluate f of 6 and g of 6 and add those together, or you can write it out like we did here, or you can simply go to your expression for f plus g of x and put 6 in place of x there. Now let's look at this last problem. I have f of g of 5 here. Now remember that when you have parentheses in mathematics, you usually start on the inside and work out. So here's this outside parenthesis. What do you see inside there? I see g of 5. Let me use this space right here. G of 5 means that you're going to go to function g and replace x with a 5, doesn't it? So I would have 8 times 5 minus 2. Well, 8 times 5 is 40 minus 2. 40 minus 2 is 38. So g of 5 being equal to 38 says I can come over here and put f and put these parentheses and replace this g of 5 with 38. Now, f of 38 means that I'm going to go to function f and replace the x with 38. So I have 5 times 38 squared minus 7 times 38 plus 4. Now we would probably want to do this arithmetic with a calculator, but since I didn't bring one, let me see if I can do this calculation of 38 squared right quick. I have, let me put just a little piece of scratch paper up here. 38 times 38, 8 times 8 is 64, I'm carrying 6, so I have 24 plus 6 is 30, 3 times 8 is 24, 9 plus 2 is 11, so that's 1,444. Okay, I have 5 times 1,444. Let's go ahead and multiply. I'll have a negative. 7 times 8 is 56. I'm carrying a 5. 7 times 3 is 21. Plus 5 is 26. Bring down that plus 4. Now I need to multiply by 5 here, don't I? 5 times 4 is 20. I'm carrying 2. 5 times 4 is 20. Carrying 2 gives me 22. 5 times 4 is 20. I carried a 2 again. That's 22. 5 times 1 is 5 plus 2 is 7. Let's go ahead and combine these. A minus 266 plus 4 is going to be minus 262. So subtracting then, let's see, I'll subtract 2 from 10 and get 8. I had to borrow. 6 from 11 is 5. Again, I had to borrow. 2 from 11 is 9, and I borrowed, so that is a 6. Again, I would strongly recommend using a calculator to do this arithmetic, but we can certainly do it by hand if we need to, can't we? I have one other example that I want us to look at. Let g of x equal 2x squared minus 5 and k of x equal 8x plus 1. We want to find g of 6. Then notice this notation. 3g of 6 means 3 times g of 6. Here we want g of 6 raised to the second power. Then we want to find k of 9. And then this expression, this means 5 times g of 6 minus 2 times k of 9. Well, let's do this a piece at a time. Let's start here. G of 6. G of 6 says we're going to go to function g right here and replace x with 6. So putting a 6 in here, 2 times 6 squared minus 5. I have 2 times 36 minus 5. That's 72 minus 5, which is what, 67? Okay, now 3g of 6 simply means 3 times g of 6. We just calculated g of 6 to be 67. So 3 times 67, 3 sevens are 21, I'm carrying 2. 18 plus 2 is 20. So 3 times g of 6 will be 201. Then here, I'm going to write that right here to save us some space. G of 6 quantity squared. In place of g of 6, I can put 67. So we're wanting to square 67. Again, let's do that on some scratch paper right quick. 67 times 67. 7 times 7 is 49. I'm carrying a 4. 6 times 7 is 42, plus 4 is 46. 6 times 7 is 42. I'm carrying 4. 36 plus 4 is 40. Again, you'd probably want to use a calculator, but we can do this arithmetic if we have to. 4,489. Okay, K of 9. K of 9 means we're going to function K, that's this one, and we're replacing X with 9. So I have 8 times 9 plus 1. Of course, 8 times 9 is 72 plus 1 gives me 73. Now, for our last part, 5 times G of 6 minus 2 times K of 9. 5 times, in place of G of 6, we can put 67, minus 2 times, in place of K of 9, we can put 73. Let's do the arithmetic. 5 times 67. 5 times 7 is 35. I'm carrying 3. 5 times 6 is 30. Plus 3 is 33. Minus 2 times 73 is 146. And then finally doing the subtraction. 6 from 15 is 9. I had to borrow. 4 from 12 is 8. I borrowed. 1 from 2 is 1. 189. What we were wanting you to see in this example is that we can use this function notation in lots of other expressions. What you really need to be sure that you understand in this lesson is f of x is a replacement symbol for y. It indicates the second coordinate whenever we use x as the first coordinate. And if we say f of 3, we're indicating our first coordinate is 3. And so we will substitute 3 for x in our equation, and whatever we get as our answer will be our second coordinate. So f of 3 will equal the second coordinate whenever x is replaced by 3. This completes the lesson on function notation and operations on functions. Please rewind the tape before you return it. Thank you.